as astrocytes react to something going wrong in the brain. If we can track this change, it's a really interesting it's very promising in terms of biomarkers of our brain imaging, to know in which brain region astrocytes are becoming reactive, when can we correct that biotherapy, etc. So there are already on the market several radiotracers that can detect reactive astrocytes, like TSPO radiotracer, but of course they are not specific to astrocytes. In fact, they were developed for macroglia, but we and others have shown that astrocytes as well overexpress TSPO. So if you use this tracer, you will see neuroinflammation in general, but not specifically changes in astrocytes. But now there are maybe a next generation radio tracer, and the tracer, which I don't remember the full name, but the BU and some numbers have been developed, and they may be more specific to astrocytes. They are increased in the brain of patient with amyloid deposition, for example. So it's a bit more difficult because we don't know really the protein or the proteins that are bound by this radio tracer. But of course, it would be really interesting to have tracers as well that would be sensitive to specific states of reactive astrocytes, to have an even better diagnosis or prognosis, to be able to say, oh, this is the kind of reactive astrocyte that are known to have dysfunctional changes, so this is beneficial, that could be beneficial in this context, or detrimental, and have a better diagnosis. So that's for brain imaging, and we can expect more tracers to be developed. And then there are the CSF or blood biomarkers, and there is a strong interest in GFAP, for example. So it's really the prototypical astrocyte protein that expresses normally in astrocyte, but is really induced in reactive astrocyte. It was the first marker really to be identified, induced in reactive astrocytes. And strangely, it can be detected in the blood. So astrocyte can shed or release GFAP to the point that is detectable in the periphery, and it can help for the diagnosis of mild traumatic brain injury, for example, or Alzheimer disease. So this is really interesting. But again, it's not very specific necessarily for one disease or stage, but I guess it can help in the diagnosis. Again, pinning down the fact that something is going wrong in the brain and that astrocytes are becoming reactive. But there are other astrocyte proteins that can be released and detected. So I think there is a lot of development to expect in this area.